Hey guys, Lightning Code here to everyone. Welcome back to the channel. If you're new, general welcome. It feels really good to be back. In this video, we're going to be covering linked lists. It's a topic that some of you have requested, and yeah, I think it's really cool, and I should probably get on that right now. So, this video is going to be a bit brief. I'm just going to create a linked list, and we're going to go over one example of using a linked list. So basically, in a general definition, a linked list is, let's say you have nodes which are just containers, and they hold like maybe a number, an object, any form of data, and they have a pointer to another node. So it's basically I like to visualize it as a box that has an arrow sticking out of it. So the box contains whatever data you want to hold, and the arrow points to the next box that contains, and keeps going like that until one of the arrows of the boxes points to none, which is null. None is null in Python, and all the good programming stuff. So that's what we're going to be working with today. We're just going to go over a brief example. I'm going to make linked list, and just let's hop right into it. So I'm first going to create a node class, and OOP, we know this is just describing what a node should look like. That's how I like to think about it. So we're going to initialize, and we're going to make this node take the data that it's going to hold. So we're just going to self.data, and this is basically us making the node class, telling it that, oh, you're going to receive a data object, and you're going to hold on to that data object. And we're also going to make our pointer to the next node. So pointers in Python, you don't need to, like, if you've had experience with C++, it's usually something like int star if you're doing like a pointer to an integer, or like whatever the data type star. For Python, it's more of just like you making a variable to point to it. So the same way like variable assignments, like p equals to whatever it is, that's a straight up pointer. All right, so let's make a linked list class. I'll just call this linked list. And our linked list class is only going to have a head pointer, so which is basically an arrow pointing to the first node that will begin our linked list. Basically the first node in our linked list, so that's what makes it a linked list. So we're going to say self.head, and I didn't spell head right. No, that's right. Oh, it's equal to none, so we don't want to point to anything, and I made that mistake there as well. I am sorry. All right, so the head pointer doesn't point to anything initially, and the next pointer of each node doesn't point to anything initially unless you set them to do that. So we have our class definitions. Let's make some nodes. So let's say the first. Wow, that was so the first node. This is our first node, and we're just going to put the data. We're going to store integers in these nodes to make it simple. So for the first node, I'm storing number 1, and if you guessed it, because you're probably there, for the second one, I'm storing the number 2, and the third, we will store the number 3. So we have created our nodes, we've given them data to hold. Now let's start piecing together a linked list. So to do this, we're simply going to set the head pointer, which is basically the arrow that we made up here, or not there, up here. So we're basically going to set the head pointer to point to our first node, which could honestly be anything, but keeping with the naming, we're going to start with the first node, which is first. So we want it to point to that. So now it's pointing to that. And now to link it up, the whole point of linking it is making the next pointer, which is the arrow sticking out of the box named first. I'm using this analogy, I'm keeping with the analogy to keep everyone following along. We're going to make that arrow point to the second box named second. So and we do the same thing for second to make it point to the third. But we don't do anything for the third because this is the end of our linked list. And if I made another node, I'd make the third point to it. But once you get to once you are pointing to your last node, automatically the next pointer of the last node points to none, which is null, which signifies like there's nothing after me, which is why, and it does that by default because of this. So now we have our linked list. So just to show how it's linked and all that, I'm going to print all the data stored in each of the nodes in the linked list. So we're going to traverse this linked list, and at each time we get on a node that isn't empty, we want to print out the data. So I'm just going to say print linked list, and we don't need parameters because we really aren't taking anything in. We're going to start by so we could, in the event where like we need to check, like in a proper interview, I encourage people to always check like if there's anything in the linked list, check for those edge cases. If this is none, then you just want to like return, like you can return anything, like you can return none or just put return, doesn't really matter. Like that's just like you checking to make sure there's actually something in the linked list. But since we already know that, I don't really want to bother about that right now. So we are going to set a pointer to, we're going to make a new pointer and make it point to the first element, which is the linked list head. So we're just going to tell it to point to whatever the linked list head is pointing to. So the first thing in the linked list. And we want to use this to traverse the linked list and just go over each node. So I want to print it out if the node is not empty. So we don't want a situation where we hit the last thing, for example, null, and we attempt to print out null, because your program isn't going to like that and it's going to throw an error and be like, there's nothing here. So we don't want our node to do extra work that it doesn't have to do. So we're going to say while P is not none, so while we are not if I can spell none, or we're not at the end, we want to print P dot data. So we're using the dot operator to just basically, every time we point to something, we are that node, and we want to print the data held in that node. So that's exactly what we're doing. And then we want to move on to the next one, and we do this simply by setting P to point to the next node that it's attached to. So wherever P dot next is pointing, whoever node we're on, we want to point to the next node after that. So we're just going to assign our pointer P to P dot next. And you feel free to take some time to like look over the code, just try to wrap your head around it, because pointers can get really confusing every once in a while because you have to keep following them. But you discover like once you wrap your head around it, it's very straightforward. So now let's just run our function. Thank you, autocomplete. So yeah, so when we do this now, we should see 1, 2, 3 as our output, and no errors, because by the time we get to the null, like when we get to null, it's going to get out of the loop and we're done with our function. And there we have it. So you can see 1, 2, 3. So that was just a brief explanation on linked lists. I So this is like linked lists you do with pointers. This is basic OOP stuff with Python, and I think this is really helpful. If you have any more questions, please leave them in the comment section. If you'd like to see something different, more examples, I'd also like to hear like some of the things you guys have, some questions you've come across that you use linked lists to solve and all that. So just leave that in the comment section. As always, if you enjoyed the video, give it a like. If you haven't subscribed, what are you waiting for? And keep doing great. You guys are doing amazing. I'll see you next week.